After learning the logarithm and exponential properties, let's go ahead and apply them in this example. Alright, in this example, the question is over here, and how do we apply this to our property? This is minus. Alright, so since there we see a plus, we multiply directly. So we log base 2 of 3 times x, or just 3x, is equal to log base 2 of 5 times x minus 2. We can simplify this by distributing 5 on x and minus 2. So let's go ahead and do that. Log base 2 of 3x is equal to log base 2 of 5x minus 10. What we can do is just raise both sides by 2. What this would do is log base 2 of 3x is equal to 2 raised to log 2 of 5x minus 10. This would cancel this out and cancel this out, leaving you 3x is equal to 5x minus 10. Now we can solve this very simple, as we have now reached the state of linear function. So what we can do is just subtract 5x on both sides, giving us minus 2x is equal to minus 10. Divide both sides on -1. So this would be 2x is equal to 10, which we know x is equal to 5. Alright, so I started this example from scratch. I did not use any calculator. I solved it with you guys. So this should be pretty easy as far as we know and remember all the concept of the rules. So let's go ahead and do another example. Okay, let's use red, and let's say for second example is log with base 10 of x plus log x plus 1 is equal to log 4x. Now you can see that there's lots of x's right here, x, and x over here. So you're getting frustrated, and how do you solve this? Well, the best thing you can do is just raise this whole thing by 10. So be 10 raised to log x plus log x plus 1 is equal to 10 raised to log 4x. So we know this is the property of addition. So 10 raised to log it would be x times x plus 1. So you directly know it's a quadratic, and this would just cancel off, giving you 4x. So this would cancel out, giving you x squared plus x equals 4x. So when you do this, it will be x squared plus x minus 4x equals 0. Okay, and after we reach this stage, what we can do is just use blank method, and blank method is plus blank equals plus 1, and blank times blank should be equal to minus 4. And when we actually find out what the solutions are, we know the solutions are over here. As first we need to simplify this. Okay, my bad. X squared minus 3x equals 0. Oh, that's pretty easy. Now we can just factor out x minus 3, and we know that equals 0. So x can be equal to 0, or x is equal to 3. So there we go. This is the solution of our problem. So sorry for the confusion over here, but let's go on and solve another problem. Alright, what if we have equation that has fractions? So let's use this example. Okay, third log base phi of x plus 1 minus log base phi of x minus 1 is equal to 2. Alright, now we see the first thing that we see is minus sign. Okay, so we have to focus on this. So it will be log base phi over x plus 1 over x minus 1. Okay, we divide, be 2. Alright, and then we want to raise this to phi log base phi x plus 1 over x minus 1 equals phi squared. We raise both sides by phi. This cancels out, gives you x plus 1 x minus 1 equals 25, because phi squared is 25. And then when you have this, what you can do is multiply both sides by x minus 1. This cancels out, leaving you x plus 1 is equal to 25x minus 25. Subtract 1 on both sides, giving you, scroll down, giving you x is equal to 25x minus 26. Subtract 25x on both sides would give you minus 24x is equal to minus 26, and then you get x is equal to minus 26 over minus 24. Okay, and when you do that, it would be approximately 1.0833. I believe that should be the answer. Alright, so we used this logarithmic property, and because it was minus, we divided, and you get the whole concept as we went through. Let's go ahead and solve another problem. The question tells us that if it's log base 2x plus log 2x minus 3 would give us 2. Well, it's the same concept. We have addition here. Let's switch color. We have addition here, so let's just go ahead and multiply first, or we could just raise it to 2, but then we'd have to do it to every side over here and here. Let's just multiply it first. So be x times x minus 3 equals 2. You get 2 raised to x squared minus 3x. Follow me here. Okay, so I just raised both sides by 2 at the same time, multiplying this thing out. This cancels out, leaving you x squared minus 3x equals 4. X squared minus 3x minus 4 equals 0. Okay, so now we have a quadratic function, and we can use blank methods here. Yes, we can. Minus 3 more multiply, it would be minus 4. Oh, we have minus 4 and 1. 1 minus 4 and 1. So be x minus 4. 1 multiply x plus 1 will give us 0. So the solutions are 4 and negative 1. 4 and negative 1. And let's see if we can use negative, because in most cases we cannot use negative. So yes, in this case we can. In this case, if the x was if if the x was x is equal to 3, we cannot use it because this would go to 0. See? Or we cannot use 0 over here as well. Do we have 0? No, we don't. So we are good. Those are the two solutions for x, and that should be your answer. Alright, for the last one, let's go ahead and solve a simple example. Very simple. That is, let's go ahead and just simplify things out. Is that what we did is that we had 4, let's see, this is a new example, 4 minus log of 3 minus x is equal to 3. Okay, so the first thing that we do here is that we subtract 4 on both sides. That's the first thing. So you get minus log 3 minus x is equal to minus 1. We all agree. Then we divide both sides by negative 1. So it will be log 3x minus 3 minus x equals 1. We raise it to 10. X 3x equals 10 raised to the first, because it just turned positive. This cancels off, giving you 3 minus x equals 10 minus x equals 10 minus 3 minus x equals 7. Divide both sides by negative 1, giving us bam bam x is equal to negative 7. And we have our answer. Bingo. Okay, so this should be pretty clear now on how you actually use those properties or laws, whatever you want to call it, of logarithm or exponential functions that we learned in past videos, and you use it in this kind of situation. Thanks for watching. I hope you enjoyed this video very much as I did solving it, and hope to see you in next sections. So take care and goodbye.